IGCSE Computer Science. Still the same at 1.3.5c. This is to describe the principles of operation of solid-state drives. So, in the last video, we looked at hard disk drives and how they, a disadvantage of them is latency. So, now we'll look at solid-state drives, and we'll see how they are a lot better. So, a solid-state drive is another secondary storage method, and this makes use of controlling the movement of electrons, which is pretty cool. So, on the inside of a solid-state drive, it may look like this, which I got online, but tell me if it's false, because I just searched these up on Google Images. I don't actually. Anyway, so solid-state drives, as said, solid-state drives remove the issue of latency, which hard disk drives have. And solid-state drives also have no moving parts, and all data is retrieved at the same time, or at the same rate, rather. At the same time, that would be quite. Most SSDs use flash technology, and what this means is that data is stored by controlling the movement of electrons within NAND chips. So you remember the NAND gate, then yeah, you can pretty much think of it like that. Data is stored as ones and zeros in millions of transistors in each chip, and this creates non-volatile, rewritable memory. And we looked at volatile RAM. We looked at non-volatile ROM. Non-volatile ROM couldn't be written to, and RAM could, but RAM was volatile. So if you turn the power off, then all the data would be lost. So now we have non-volatile, rewritable memory. And this is pretty cool stuff. Some SSDs also use EEPROM technology. And this means that data is stored by controlling the movement of electrons within NOR chips. And so note the difference, NAND and NOR. And this makes them faster in operation, but more expensive than flash technology. Now, if you remember back when we looked at logic, we talked about logic building blocks. Now, NAND and NOR gates are logic building blocks. With NAND or NOR gates, you can build any other logic gate. However, we usually use NAND because it's a lot cheaper. So that's why most people prefer NAND. And this is kind of the same idea here. NOR is more expensive, so this technology is more expensive. EEPROM technology also allows data to be read or erased bytes at a time, while flash technology only allows data to be read in blocks. So we'll look at advantages of SSDs over HDDs, so it's sort of a summary plus a few other things thrown in. So faster data access, yep. More reliable, no moving parts. So this is a good one because we look at hard disk drives and we see that these platters are moving. These read-write heads are moving. But with solid-state drives, nothing's really moving. There are no moving parts. And if you remember the toy car that we looked at in the primary memory video, here's an advantage of using solid-state drives for the toy car. And this no moving parts allows them to be very thin. It also allows them to be lighter in weight, if it's very thin, because, the thinner, the lighter usually. There's also no need to wait for them to operate at full speed, and they don't heat up as much as, again, other advantages of using solid-state drives in the toy car. So, yeah, that's pretty much it for solid-state drives, and we can finally move on to offline storage in the next video.